So 9-7, solving nonlinear systems, is going to be split into two pieces. First thing we're going to do is systems of equations, and then video B is going to be systems of inequalities. That's going to be more graphing stuff. So solving systems of equations, we've done this before with lines. We've done the substitution method, the elimination method. We even solved by using like Cramer's rule, inverses. We're not doing Cramer's rule and inverses here, but we will be doing the substitution and elimination method. So basically, it's going to be grouped into two different sections. We're going to have a system first of one linear equation and then one nonlinear equation. And then our second half of this video will be two nonlinear equations. So with this one, possible combinations could be 0, 1, or 2 solutions. So when you have a line and something that's not a line, you know, either a circle, ellipse, hyperbola, or parabola, the system may have 0, 1, or 2 solutions. Okay, so here are just some different ways that could happen. So 0 solutions, you know, maybe you have like a parabola, for instance, and the line just kind of runs right underneath it. That's one way to have 0 solutions if they never ever intersect each other. One way to have one solution would be, let's say that we have a circle, that's a nonlinear equation, and then maybe the line just comes through and just perfectly skims it just at one point and then goes off the other side. That would be how to have just one solution. Most of them are usually going to have 2 solutions. So say it's something like, you know, an ellipse like that. And then our line goes through like this. This is the most common one that you'll see, is when you have the line intersecting whatever the shape is at 2 different places. So either 0, 1, or 2 solutions. With a line, it's not possible to have any more. So let's look at some of the algebra techniques that we're going to use to solve these. So here's one. We've got a system of equations. So this one, we should hopefully be able to recognize this from the last section as a hyperbola, because you have an x squared term minus a y squared term. So this is a hyperbola. This is a line. So solving the system of equations. So I'm going to give you guys some different techniques that you could use. It's either going to be substitution or elimination. If you have, you know, x squareds compared to x's, y squareds compared to y's, this is going to be something where you'd want to use substitution. So substitution will be our best bet here. And that's because these are never going to eliminate because they're not the same variable. If you have the same variable and you could get them to eliminate, then elimination would probably be easier. So the way we're going to do this, we're going to take this equation right here and get the x by itself, okay? Because it's pretty much already x, or already by itself to begin with. So we can subtract 2y from both sides, and we will get x equals 2 minus 2y. So remember, the way that substitution method works is you rearrange one of the equations, but then you take that expression and you sub it in to the other equation. So instead of this x right here, we're going to replace it with this expression, because this expression tells us that x is equal to 2 minus 2y. So I'm going to take this expression 4, but then instead of x squared, I'm going to replace it with 2 minus 2y. And then the rest of the equation is exactly the same. So squared minus 16y squared equals 25. So notice that my equation now just has y's in it, so I'm going to be able to solve for y, and then I'll sub that back in and solve for x. So that's how it'll work. So first of all, remember, having something being squared, you cannot just square both terms. It doesn't work like that. You've got to write it out twice in FOIL. So keep the 4 kind of right here where it is. We're going to FOIL this out. So we'll have 2 times 2, which is 4. 2 times negative 2y, negative 2y times 2, and negative 2y times negative 2y. Okay, so distribute that 4 to a lot of different pieces. These are all 4s, so they all become 16, so when we multiply by 4. Okay, so we're getting there. We've got just a 16, and then these two become a negative 32y. And then these two, when I add them together, they just cancel each other out. So I just have the 25 on the other side. All right, so in solving for y, I will subtract this 16 from both sides. I get negative 32y equals, and this becomes 9. So this lovely y value that I will have here is negative 9 over 32. And there's really, unfortunately, nothing that will reduce down to. So remember the way substitution works. You take this y value and then sub it in right here, and you'll get the x value. So I will have x equals 2 minus 2 times this new value of y that I got. Okay, and I'm just going to simplify that as much as I possibly can. All right, so 2, and then negative times negative would be positive. But then this 2 over 32 can reduce down to 1 over 16. So this will be plus 9 over 16. And now, finally, to get my answer, I need to get a common denominator. So to get this to have a denominator of 16, I will multiply by 16 over 16. So this will be 32 over 16, which is the same as 2, plus 9 over 16. And when I add those together, that will give me 41 over 16. Okay, so lovely values here. Here's my x value, here's my y value. Remember, x, y values get written as coordinate points, so my coordinate intersection point would be this. Very pretty numbers there. All right, second option is if we've got two different conic sections, some sort of combination of parabola, circle, ellipse, hyperbola. We've got multiple options here. You can have anywhere from 0 to 4 solutions. Anywhere from 0 to 4 solutions. So I will give you a sample of how all of that could happen. So let's say, you know, same scenario as before. You've got a circle, and then, you know, on the opposite sides of it, you have a hyperbola, something like that. That would be 0 solutions. One solution, let's say that you had an ellipse, and then the parabola just came through and just bumped it at one point. That would be one solution right there. Two solutions, let's say that you had a circle and a parabola came through like this. Okay, then you'd have an intersection right here and an intersection right here. That would be 2. Really similarly, let's say that we had a circle and then the parabola came through just a little bit higher and did something like that. That would be 3, because it would intersect here, just kind of bump it right here, and then right there. And your final option would be 4. Let's say we had an ellipse like this, and then maybe a circle like this. Almost looks like an orbit sort of situation. We've got 4 intersection points there. So anywhere from 0 to 4 solutions, really anything is possible with those. So let's walk through how to do the systems of equations here. So these are going to be a little bit easier because you get to do the elimination method instead of the substitution method. So with these, when it's two different conic sections, you're going to want to go with the elimination method. The reason that works here and it didn't work up there is because, see, I have y squareds on top of y squareds or x squareds on top of x squareds, depending on how you choose to do it. So with this one, pick one of them to eliminate. It's probably going to be easier to eliminate the y squareds. So what you do is you just pick one of the equations and multiply it by a -1. So we're going to multiply every single term by -1. I'm just going to line it up right underneath this one. And then we'll get these to eliminate. So this will leave me with a 3x squared equals, and then 23 minus 16 is 7. So you'll notice these are not going to come out all that pretty. None of the answers in this section are. So here these 3's will cancel. I will get x squared equals 7/3. And so my answer, remember to get this x by itself, I've got a square root. And do not forget, when you are solving equations, if you square root, as part of that, you've got to include a plus or minus. Okay, so we've got either a positive or negative square root of 7/3. Okay, so I'm going to plug this into my first equation or my second equation. Doesn't matter. You can do whichever one you want. I'm just going to plug it into the first because it looks easier. So I will plug first the positive square root of 7/3 squared, and then plus y squared equals 16. Okay, so if I square this square root, I have just 7/3. And then I would subtract this 7/3 from both sides. So I have y squared equals, now of course I can't combine these the way they are because they have different denominators, but I can write the 16 as 48/3, which is the same as 16. I just write it to get a common denominator. So this gives me 41/3. But remember, I'm not done until I take the square root. And when I take the square root, you got to make sure you have a plus or minus. All right, so y equals plus or minus 41 over 3. So when I plug in the positive square root, I could get either positive or negative 41 over 3. So let's keep track of what we've got so far. So when I plug in the positive 7/3, I could have either positive or negative square root of 41 over 3. So I've got 2 points so far. So let's see what happens when I plug in the negative square root. Okay, so when I square this, even when I square a negative, it still comes out to be 7/3. So if you look right here, this equation and this equation are now the same. So we know that we're going to get ourselves to the exact same solution because these equations were identical once we got through it. So we know we can subtract the 7/3, add this to both sides, square root both sides, we're going to get this. So we actually have 4 solutions because this tells me if I plug in the negative square root of 7/3, I either get positive or negative square root of 41/3. Okay, so 4 total solutions there. So that's going to be one of those scenarios like I saw up here with 4 solutions. This one is a circle and this one is an ellipse, so it's going to be remarkably similar to what you see right there. All right, last one. Let's look at one more. So this is a circle because I've got x squared plus y squared and the coefficients are the same, so we know that one's a circle. This one's going to be a parabola because I have just an x squared, no y squared. So for a circle and parabola, we really have, you know, any form of options here. So let's see how many we're going to get. So we're going to do elimination again, and these x squareds can cancel out. So let's multiply everything up here by a -1. So I'll line this up. Negative x squared minus y squared equals -8. So these will eliminate. Be really, really careful with the y's. The y's do not eliminate. You can't actually even combine them because one is a y squared and one is a y. Okay, so this I would just have to write separate, like negative y squared, positive 3y. They're not like terms, so you can't combine them. Then I have a 2 right here on the other side from the 10 minus 8. So anytime you have a quadratic equation like this, your goal is to get everything on one side and then to solve by factoring. So since this is negative, let's move everything to the other side. So I'm going to add my y squared. I'm going to subtract my 3y, and then the positive 2 is already there. Okay, so when I factor this down, I am looking for, I've got my y times y for y squared. I'm looking for 2 numbers that multiply to positive 2 and add to -3. So they'd both be negative, and you'd have -1 and -2. So that will provide us with 2 different y values. I will have y equals 1, and I will have y equals 2. So 2 separate values to plug in and see what we get for x. So let's plug into the first one, or the second, doesn't matter. Literally, you can do whatever you want. So if we plug in 1 into the first one, we will get x squared plus 1 squared, which is 1, equals 8. Subtract that 1 from both sides. I get x squared equals 7. And when I square root, when you are solving these equations, do not forget your plus or minus. Okay, so here's what I have so far. If I plug in 1, I could get the positive square root of 7, or I could get the negative square root of 7. So 2 points so far. And then let's plug this 2 in. So x squared plus 2 squared would be 4 equals 8. And same steps basically as the previous one. Subtract that 4 from both sides, I get 4. And then square root both sides. Don't forget your plus or minus. So you get plus or minus 2. Oops, these, okay, sorry. I just realized I did something wrong. These are the x values, these are the y values. So we should have positive root 7 with positive 1, or negative root 7 with positive 1. Sorry about that. Swap my x's and y's. Here I could have positive 2 with this 2, or I could have negative 2 with this 2. Okay, so again, 4 intersection points. Keep in mind, it is possible to have 0, 1, 2, or 3, as well as 4. I think this starts our B video. Yes.